Okay, today we're talking about the mathematics of finance. All right, so we're going to talk about compound interest, simple interest, continuously compound interest, and probably what is a new thing, annual percentage yield. So the first thing we're going to talk about is simple interest, though. And this formula you're probably familiar with, but we'll just kind of lay out, really, in both formulas, what each part is. So P represents the principal. Okay, that's the amount of money that you're investing in some sort of account, right? R is equal to the rate. That's the interest rate, and it's expressed as a decimal. Okay, and then N is equal to the number of years. So number of years. Okay, and that holds true in both of these formulas. Okay, so simple interest and annually compounded interest. Okay, so let's see how this might get used in a problem. Suppose George invests $5,000 at 5% simple interest, and Quan Lee invests $5,000, should be $5,000, sorry, $5,000 at 5% annual compound interest. Compare the values after 10 years. Okay, so one of them is using simple interest, the other is using compound interest. So let's see. We'll just start with the simple interest one. So A is going to be equal to 5,000, that's the principal, times 1 plus N times R. So that's going to be 10, that's the number of years, so 10, times the rate as a decimal, so 0.05. And that ends up being $7,500. Okay. So we'll go check for compound interest then. For compound interest, we'll have A equals 5,000 times 1 plus 0.05 raised to the 10 power. All right, when you compute that, you get 8,144 times 47. I should kind of explain what compound interest does. So the way compound interest works is if you invest $5,000, you get 5%. That gets added to your total amount at the end of the first year. Then that new amount, which would be 5,000 plus your interest, is your new principal. Okay, so then that gets added, and that gets an interest added to it for the second year, and that gets added to the principal. So every year you're adding money to the principal. You're accruing interest on greater and greater amounts. That is not the case for simple interest. Simple interest, you just apply the interest rate 10 times to the original principal. The principal doesn't change each time. Okay. Now, there's different numbers of times per year that you can compound. The first one we talked about was annual compound interest. That's 1 time per year. Excuse me. The other way that you can do it, or there's other ways that you can do it. Interest compounded at any K times per year. So some common ones are, well, once per year, but biannually, or semi-annually, which is twice a year, quarterly, which is 4 times a year, monthly, which is 12 times a year, and so on. So up to daily if you want. There's tons of different variation. So in here, T is equal to the time in years. And again, K is the number of times it's compounded per year. Okay, so let's do an example here. So suppose Roberto invests $500 at 9% annual interest, compounded monthly. So that means it's going to be compounded 12 times per year. Find the value of the investment after 5 years. Well, with these problems, I like to make a list of everything that I know. So I know that the principal is equal to $500. That's what I'm investing initially. R is equal to 0.09, 9% expressed as a decimal. T is equal to 5, because 5 years. And K is 12 because it's compounded monthly. All right, so we can take all of that and plug it into the compound interest formula. Here's what we get. A equals 500 times 1 plus 0.09 divided by 12, all raised to the 12 times 5. You can plug all that in your calculator together. You might want to put the exponent in parentheses. When you do that, you get the final amount is 782.84. Okay, so in just 5 years, that $500 becomes almost $800 if you're compounding monthly. Okay. Next one. Judy invested $500 at 9% annual interest, compounded monthly. How long will it take her to investment to reach $3,000? This is a different kind of question. We're not saying take the 500 and then compound it or invest it for a certain amount of time. In this one, we want to know the amount of time. Okay? So here, the final amount is $3,000. We want to know how long it's going to take to get to $3,000. So I'm going to plug in $3,000 in for A. I got $500 as the principal. Times that by 1 plus 0.09 divided by 12. Still 9%, just like the last problem. Raised to the 12t. And I want to solve for t. And what you're going to do to solve for t is you're just going to try and solve, you're going to graph the left and graph the right. And you're going to figure out where they cross. That x value where they cross, that's the amount of time it takes to turn that 500 into 3,000. So when you graph them, you end up finding the intersection at 20, at x equals 20, approximately. So after 20 years. You might want to try that real quick and see if that's what you end up with. See if you're typing everything in correctly. Kennedy invested $1,500 at 6% annual interest compounded monthly. How long will it take her investment to double? Okay, again, slight variation on the last problem, but not too bad. If Kennedy starts off at $1,500 and wants to know how long it'll take to double, then your final amount is going to be $3,000. So it's very similar to the last problem. You want to know when is 3,000 equal to 1,500 times 1 plus 0.06 divided by 12 raised to the 12t. So again, you're going to go and graph the left, graph the right, and find where they cross. You find out that it's about 11.6 years to double her money. Okay. Now, if we looked at a table of frequency for compounding interest, you'd find that the more you compound, the more times per year you compound, the more money you make over the course of the year. But there is a limit. Okay, so in fact, if you compound continuously, what you end up with is a simplified version of the compound interest formula. You end up with this, what we call sometimes the PERT formula. It's A equals P, principal, times E, the number E, raised to the rate times time. Okay. So this is not that bad to use. In fact, it's clearly simpler than the other formula. So we can just take this example here. Suppose Letitia invests $100 at 8% annual interest, compounding continuously. How much is her investment worth after 1, 2, 3, 4, 5 years? So all you need to do is take your calculator, type in the principal, which is 100, times E raised to the RT, so 0.08 times the amount of time. So we're starting off with 1 year, and you get 108.3. And then if you hit second and entry, you can copy that, and instead of 1, you can put 2. And you can change it to 3, and you can continue to get all those values. So I've got them listed here. So for 1 year, you get 108.33. For 2 years, you get 117.35. For 3 years, you get 127.12. For 4 years, 137.71. And for 5 years, you get 149.18. Okay? Again, it's just plugging into the formula. All right, annual percentage yield. This is the percentage that if it's compounded, if some investment is compounded annually, would yield the same return as if it was as the given interest rate with the given compounding period. So what does that mean? So imagine you have two investments. One of them is investment at 5% and compounded monthly. Another one is at 6% and it's compounded quarterly. And you were trying to compare these investments. Which one is a better one? Well, the problem you run into is that the compounding periods are different. It makes them hard to compare. So what we do to deal with that is we have a formula for creating the annual percentage yield, and that just makes its output tells you the interest rate if it was compounded just one time per year. Okay, so let me give you that formula, and I can show you a couple examples here. So the formula is this: 1 plus the annual percentage yield, the APY, okay, is equal to 1 plus r over k raised to the k. So let's do an example here where we have to find the annual percentage yield. Ursula invests $2,000 with Crab Key Credit Union at 5.15% compounded quarterly. What's the equivalent APY? So notice over here the principal does not matter. You can figure out the APY without the principal. So the $2,000 here is information that we actually don't really need. So let's set up the formula. We'll go 1 plus the APY is equal to 1 plus the rate, which is 0.0515, all divided by k, which is 4 because it's compounded quarterly. It's 4 times per year, all raised to the k, which again is 4. Okay. So when you compute this on the right, you'll get 1 plus 0.0515 divided by 4, all of that raised to the 4. You get this number, and then the last step would be to subtract 1 to get your APY. So your APY turns out to be 0.0525. In other words, 5.25%. So if this investment was compounded 1 time per year instead of 4 times per year, this is what your rate would be, 5.25%. Okay, last one. This is a classic annual percentage yield question because it's comparing 2 investments with different interest rates, and you want to know which one is better. So the first investment is at 8.75%. So we'll set up our formula. 1 plus the APY is equal to 1 plus 0.0875 divided by 4 raised to the 4. And when you solve this, you get that APY is equal to 0.0904. In other words, if we convert that to a percent, it's 9.04%. So you just plug this thing on the right into your calculator and then subtract 1. Okay, and then we'll check the other investment. That again is 1 plus the APY equals, and here we have the different interest rate. So 1 plus, and it's also different compounding. So 1 plus 0.087 divided by 12. That's all raised to the 12th power. Again, plug that into your calculator, compute it out. So you get 0.09055, and so that turns out to be an APY of 9.06%. So that second investment is a better investment. The one that you're investing at a lower percentage, but it's compounded more frequently, so that ends up making you more money if you were to equalize both of the investments to compare the amounts that you'd make.